All right, everyone, take your seats. Let's get started. Everybody got a seat? There's some seats in the front over here. Okay. So are we ready? Are we ready to hear some awesome talks today? Yes? What? You can't wait for the weekend, right? Well, it hasn't come yet. We're still going to work really hard today. We're going to work very, very hard. I think we're working until 6:15 this afternoon, which is half a day for you guys, right? You guys probably work more than this normally. You probably work 18 hours a day. That's what I know. Most of the developers that I've gotten to know probably work best later in the afternoon or late in the morning. So welcome everybody. I'm Stavros. I have the privilege of coming on stage every now and again and announcing the next speaker, and maybe throwing a few cracks and jokes every now and again. Patroklo, thank you very much for inviting me. It's an honor to be here. I heard about Voxxed last year when Patroklo put up the first Voxxed in Thessaloniki, and it seems that Thessaloniki is like moving so much faster than Athens is in terms of the ecosystem development, right? Especially around developer events. They're doing some amazing things. Patroklo, thank you for coming to Athens. On behalf of all of these 450 people who've taken all these seats today and bought all the tickets and supported Voxxed Days Athens, it's fantastic to have this event, and thank you for all your effort and putting it together and bringing all these awesome speakers, bringing all these awesome sponsors, pushing the needle forward. So without further ado, let's get started. I'm going to hand the microphone to Patroklos to say a few words, and we'll get started with our first. Now, the applause I want like a good Friday afternoon, for Friday morning applause. Friday afternoon will be a little less. But Patroklos, go.
Thank you very much, Stavros. Welcome, everyone. Kalimera. Good morning. I'm excited. Okay, you can see it, of course. It's the first year we're organizing Voxxed Athens event. As Stavros said, we had 6 months ago the first Voxxed in Thessaloniki. It is a 3-day event. It started yesterday with a couple of workshops, 3 workshops, and it ends tomorrow with a final workshop, and today is the main conference day with 24 different speakers, 20-something sessions, 10 different sponsors, 11 sponsors. We have sold out our event. 450 people are in this building attending the event. I think it's great for a first-year event. There is an error. There are not 3 countries. There are 13 countries joining, okay, obviously. I mean, that's an error. And first of all, I would like to thank our volunteers. Did a great job, okay? So far, you've seen them already. And I would like to thank our sponsors. Give a big applause to our sponsors. Without them, we wouldn't be able to do them. Thank you very much. They have lots of surprises, lots of good stuff. We have plenty of time during breaks. You can visit them and you can discuss, chat, meet them wherever you want. Now, a few practical things. This is the main room. It's called Silk A. Atrium is on the 2nd floor. This room, during the first coffee break, will be split in 2 rooms. It will be Silk A and Silk B over there. Toilets are in front of the registration desk and backwards, just before the stairs. We have, you will see at the exits, there's an ice machine. You can have a look. And you are kindly requested to push only the green button, okay? Nothing else happens if you push the other buttons, and give your feedback to our amazing speakers. What else? We have an after party, okay, at 6:30. I think you all got this green beer mark, okay? You can use it to order your free beer, okay? Plenty of coffee, food, coffee again, and beers after party. Enjoy the event. I will pass the ball to Mark. Mark is co-founder of Voxxed, and he has a few things to tell you about the event. Thank you very much.
There's a stage, I may as well use it. That's because I'm egotistical. So, good morning, Kalimera. My one piece of Greek. I'm pleased that I got it out of the way and didn't say squid. So that's good. I'm just going to say a couple of things. I'm the co-founder of Voxxed, and my job's really easy because all I do is help people like Patroklos, people who are incredibly committed to bringing events and communities and knowledge sharing to local areas where, for any reason, it's just been neglected. And last year in Thessaloniki, he did an amazing job, and then he said, I want to take this to Athens immediately. And the amount of passion that he puts into doing this, I mean, he's got a day job, and he spends his evenings and weekends and all his free time making this kind of thing happen. So the real star of the show right now is this man, and can you please give him a big round of applause? Those of you who don't know what Voxxed is, we set it up a couple of years ago, specifically to do that, to be a place where developers could share knowledge with other developers in a non-commercial environment, in the sense that we had a website where there was no advertising. And this came out of the DevOps movement. If anybody's ever been to a DevOps event, there are 6 of those around the world now. And we were approached by some people who said, we want this kind of event locally. And this is where Voxxed Days was born. And again, it's the passion of these community leaders who make it work, and they bring all of the speakers together, and they bring all of the sponsors together in order that you guys have got something on your doorstep that you can come to, and you don't have to fly all around the world to go and see great content. So I hope that you enjoy the next couple of days, or the next 7, 8, 9 hours. Sorry, I'm in other conference mode talking about different days there because we had a workshop day yesterday. So yeah, really, really hope that you enjoy today. And please give feedback. It's so important that you feed back to Patroklos and the team everything that you see, whether what's great and how we can improve as well, so that we can make it better for you in years to come. Thank you very much. I'm going to hand over now to Stavros, and have a great day. Thank you.
Very much. Thank you. Okay. All right, it's time to introduce our first keynote speaker. I'm going to quickly read the profile here, and then I'm going to stop in the middle of reading it and say something else. But let's give it up in a few seconds for Simon. Simon Brown is an independent software development consultant specializing in software architecture and the author of Software Architecture for Developers. It's a developer-friendly guide for software architecture, technical leadership, and the balance with agility. You guys are kind of agile guys. And much, much more. When I asked him, you know, where do you live? He goes, you know, I'm from an island. I'm like, okay, some of us are from islands as well. So he hails from the exotic island of Jersey. And I asked him, what's important about Jersey? Isn't it a tax haven? Me immediately, right? The Greek guy. It's like, where is the tax haven? He goes, yes, it's a tax haven. Very, very sternly. He said, yes, it's a tax haven, but it's also famous for cows. Cows and tax. Simon, welcome. Big round of applause, everyone.
Thank you. Good morning, all. Kalimera. That's also my whole Greek. Now we're done. So, hello, welcome. We're going to talk about software architecture. But I am going to take you on a journey first. So what's the year? What year is it? 2017. See, that wasn't a trick question. Let's imagine it's actually 2067, and we finally invented teleportation. Hooray! And I teleport us right now to here. Where are you? Shh. So there are a couple of ways to solve this problem. Number one is you walk up this leafy lane, and maybe you bump into a man walking this dog and say, oh, hello, sir, I'm lost. Terribly sorry, can you help me, please? And you try and figure out where you are. But we're geeks, aren't we? So what you do is you get your phone out, You open up the Maps application, you press the dot to use the GPS locator, and it shows you you are here. So where are you? Does this solve the problem? Well, no, it just kind of tells you where you are to in a larger area. But we have technology. So what we can do is we can zoom out. And there we go. This is Jersey. So this is my little island I live on. It's 9 miles by 5, population 100,000 people. It's British, not English. Don't ask me about recent political events because I don't understand. We have our own money, and our own money does have a cow on it. I have one with me. Come find me in the break, I'll show you. This is quite a complex map. It's very green. It shows we have lots of green stuff like fields and farms and cows. But it's a tricky map to navigate. If you wanted to get from this blue dot to the other side, it doesn't look like you have many options in terms of the roads. So again, we can use technology and we remove the satellite imagery. And now Jersey gets a bit clearer. Now we can see there's a really small, intricate network of roads and lanes. Who knows where Jersey is? Sort of, maybe. So again, we can solve this by zooming out. So now we can see there's the tip of France there. We keep zooming. It's south of the UK, north of France. Not quite a Mediterranean climate, but whatever. We zoom out further. We zoom out further. There we go. Anybody been to Jersey? 2 people, 3 people. Right, so your challenge this summer is to come and visit me in Jersey because we have amazing weather. No, we don't. Well, when you come through the airport and the harbour, pick up one of these things here. It's a map. It's a visitor map. And the visitor map tells you the stuff you want to go and see. And it looks like this. Pretty standard kind of visitor map. It's mostly accurate. It's got some sites, some points of interest. Not everything is named, but it's a good starting point for exploring our little island. There's a zoom in on the town. Got some road names, a bit more detail. This is mostly accurate. So that thing there is a marina. It's colored blue, implying there's water. There is for half of the day. So we have incredibly large tidal movements. So if you drive your boat and park it there, you come back 6 hours later after some shopping, tax-free of course, and your boat's on its side. So again, this is mostly accurate, but doesn't tell you everything. Compare this to like an ordnance survey map. So this is very detailed. It's produced using modeling. Nowadays, we just fly a drone around, take some aerial photographs, do some surveying. This is showing you lots about the topology and the contours and the shapes of the road and the shapes of the building, and it's super, super high precise. Very, very accurate. But it requires a bit more know-how to interpret what's on this map. Something all of these maps have in common is points of interest. So when you come to Jersey in the summer, which you should, of course, you should come and visit Elizabeth Castle. This is a small island off the south coast of our island, and it's a 15th or 16th century castle. Why? Because the French or the British kept invading for some unknown reason. So it was put there to protect us. And it's beautiful. Gorgeous granite stonework, some lovely architecture. And there's a natural high point in the center of this castle. So you walk around the castle, avoiding the rain showers, of course, and you get to the middle, and you look up, and you look up, and you look up, and then suddenly, wow, there's this really ugly concrete thing stuck on top. And you're like, what on earth is that about? And it turns out when you're walking around the castle, there are a bunch of signs telling you about the history and the culture. In World War II, Jersey was one of the few places occupied by the German forces. They imported a load of concrete. They refortified the existing fortifications. And all of these stories are told on the signs. How do you find this information out? You just go grab a travel guidebook on your way through the airport. Has the maps, the points of interest, the sites, the culture, and so on. So that's my advert for Jersey done, since I'm sponsored by the Jersey Tourism Board. I joke. We'll come back to this stuff later. It has some relevance to architecture diagrams, believe it or not. So why is all this stuff important? Well, imagine you're a software developer, you're an architect, you work in a software team. There are lots of other people around your organization who might want to know something about what you're building. Other tech people, non-tech people, investors, sponsors, and so on and so on and so on. So when I talk about architecture diagramming and documentation, really there are 2 key purposes. Number 1 is communication and learning. So telling people what we're building, how it works, and also onboarding new joiners. to our team. There's a secondary, really kind of interesting use that we often don't talk about, and that's architectural improvement. So if you have some sort of idea of what your system looks like, you can do some good architecture refactoring. You can spot those hotspots and those tangles and things. So this talk is called The Art of Visualizing Software Architecture, and it is a bit of an art. One of the things I do, one of the things I did yesterday here in Athens, was I ran my architecture diagramming workshop. And it's a really, really simple workshop. Here are some requirements. Create groups of 2, 3, 4, 5 people, go away for an hour and a half, do some design, draw some pictures. That's it. Here's a picture from a real workshop, not the one yesterday. A real picture from real workshop. It's just a bulleted list of technology choices. There's nothing interesting about this picture whatsoever. This is another picture I call boxes and no lines, because it has boxes but no lines. This is what people often refer to as a functional view. Imagine you're having a nice house built somewhere in the countryside, and you ask your building architect to draw you a functional view of your house. Eating, sleeping, dining, entertaining. It's not a particular way to describe a software system. This next diagram is one of my all-time favorites. I love it. Look at that. This diagram, the center of this diagram, tries to show the overall steps in the process implemented by this the system, the set requirements. This thing here is important because everything points to it. Next time you go up in an aeroplane, although we have invented teleportation, of course, but when you go back in an aeroplane, pull out the magazine in the seat pocket, flick to the route map. This is what the route map looks like. That's like Frankfurt or Heathrow or Schiphol. On the other side, we've got different boxes, styles, shapes, colors, all sorts of craziness going on. And this box here says UI upside down. And you know why it says UI upside down, don't you? Because somebody was writing that from the other side of the desk. It's just laziness. Without knowing anything about the systems you are building, this describes your systems. The red box is your system. Inside your system, you handle errors, you transport data in and out, you create reports, and you probably do some, wait for it, business logic. Yay. This is what people often refer to as a logical view. It's one of those very silly, fluffy, conceptual diagrams. Doesn't really make much sense. Here's another one. Doesn't include technology choices, but at least it tells us something about what the system is doing here. You've heard of POJOs, plain old Java objects, and plain old C# objects. This is the homeless edition, the HOCO. There's a bunch of C# objects kind of randomly floating around a database for some reason. Another one of my all-time favorites. When I was a kid, we had these storybooks. They were called fighting fantasy books, choose your own adventure books. And basically what you would do is you'd start reading through like 10 or 20 pages, and you get to choose the story depending on which page you turn to next. Anybody read these? Yeah, a few people nodding. This diagram is the same sort of thing. You start at the top, you go down through the picture, you get to follow different paths, the fail events, the complete events, the reject events. Now, when I read these books as a kid, my character always died, which was really annoying because you have to start from the start. The diagram's the same sort of thing. All paths lead to this trap on the left-hand side here. There's a little stick man in the corner. I really like having little stick people on my pictures because it tells us something about, who the users are and how they're interacting with our systems. But we need to give them a name, otherwise they're just stormtroopers. Faceless clones attacking your system, and that's probably bad. Whiteboards, we always say whiteboards are useful to have. Look, this is what happens if you don't have a whiteboard. We scrub things out. We don't need this line. Oops, yes we do, we put it back, sorry. And we say naming's hard. Yeah, let's rename some stuff. And if you take this to its logical conclusion, you get stuff like this. Right, these are real diagrams from real workshops. I literally have 15 or 20 gigabytes of photos from previous workshops. We could just sit here for the next 3 days and show you, but we'll stop there. So this workshop's fairly easy. The design part's fairly trivial, but it's the diagramming aspects people find complex. And when I'm wandering around the classroom and I'm kind of listening into what people are saying, sometimes the groups draw a box or a shape or a line, and they'll actually say this out loud. Yeah, here's this thing, it doesn't make sense, but we'll explain later. And there's always this weird perception that we're going to present our architecture diagrams And I used to do that in my workshops, but I don't do it anymore because it's boring. So what I do instead is a really nasty twist. People are working away in their groups, they have like an hour and a half of context, discussions and conversations, and then I get them to switch diagrams. And guess what happens? You get this gigantic what moment, because nobody understands what anybody else has done. You know, all the context has been completely lost. And people say, well, yeah, we don't understand the color coding, the lines don't make sense, the acronyms don't make sense, the boxes don't make sense, the shapes don't make sense, and just nothing makes sense. One of the comments in my workshop yesterday was, oh my goodness, this is a gigantic mess. Yep. So you ask people what's challenging about this, and they say, yeah, we don't know where to start. What type of diagrams should we draw? What notation should we use? What level of detail should we show? It's tough. It seems as software developers we can design software. But it seems as software developers we can't draw those pictures. And it seems odd that the complexity here is in the drawing pictures, not the design. Now, caveat time. I have no empirical evidence to back any of this talk up, at all. No research, no academic papers. However, I have done this workshop a couple of times in the past for about 10,000 people in 25 plus countries. And of course, now I can add Greece to my list. And everybody struggles with this. And that seems a shame, because one of the big things we've tried to do in the agile kind of movement and world is focus on good communication, moving fast. And if you can't communicate well, you can't move fast. It's as simple as that. And really, architects struggle to describe architecture. Whenever I run these workshops, sometimes my customers say, look, Simon, we're really happy to get you in. We're going to send our best, most senior architects along. And I go, oh no, please don't. Because they're typically the people who get this the most wrong. And it's the junior developers who have a much, much better understanding of the code and therefore can draw diagrams that reflect the code. So, imagine your manager comes to you on Monday and would like you to draw some pictures to describe your software for diagrams or documents or presentations. Where do you start? Well, you could go and ask Google what it thinks a diagram looks like. And if you do that, you get pictures like this. Page after page after page of Visio, PowerPoint style block pictures. Do you see these diagrams in your offices? No, because you don't have diagrams, right? I see these things all the time. These are typical kind of architecture pictures. Now, you might be thinking, this guy's talking about software architecture. He's not mentioned that horrible three-letter acronym yet, UML. So let's do a quick poll. Who here uses UML? I think we can do this on two hands. 1, 2, 3, 4, 5, 6, 7. Yeah, it's less than 10. Out of 400 people, that's amazing. And that's reality these days. I've asked this question all around the world, and optimistically, I think it's like 1 in 10 people. So this raises an interesting question. Why don't people use UML? And UML is useful. I do use UML. It's great for showing low-level details and precision and stuff like that. But I don't use it for architecture. Bunch of reasons, but it basically doesn't have the right abstractions and diagram types that I want to use as a developer to describe architecture. Now, of course, none of this is a new problem. Philip Cruikshank, back in the late 90s, created the 4+1 model. Philip was one of the RUP guys. And he says to describe a software architecture, a software system, we use a model composed of multiple views or perspectives. This is what the 4+1 model looks like, if you've not seen it before. Basically, you take a scenario, a use case, a feature, a story, and you document it from a bunch of different angles. And normally there's a logical view, which is the fluffy conceptual building blocks, and there's a development view that talks something about the code. This is not the only approach. A friend of mine, Owen Woods, wrote this awesome book called Software Systems Architecture. In this book, they have something called viewpoints and perspectives. And what they've done is they've taken 4+1 and they've extended it. In extending it, they also changed some of the naming so that there's a functional viewpoint, and that kind of maps onto the logical view in 4+1. And every architecture book does the same thing. So we have a set of naming conflicts here. The bigger problem from my perspective is most of these approaches to architecture have a logical view and a development view, and that's separate. And this bugs me. Why are we taking in these two very different views of our software system? And I think it stems back, if you go back to things like SSADM, for those of you who are old enough, there was a logical design phase and a physical design phase. And maybe the logical design phase was done by the architects, and the physical design phase was done by the developers. So maybe that's what bred all of this stuff. Not sure. My problem with the logical development view split is basically you get a bunch of diagrams that never quite match the code. I see this a lot. I see organizations and they have these beautiful looking architecture diagrams. And then you ask the developers, so are these useful? They go, not really, they don't match the code at all. But they look nice on our walls, they're hiding a crack or something. George Fairbanks wrote a fantastic book about architecture. And in this book he talks about the model code gap, and it's exactly this problem. So we have a nice architecture diagram on our wall. We have a bunch of boxes on that diagram. The boxes represent abstract concepts like components, modules, subsystems, services. Quick show of hands, who here is a Java developer? That's a good chunk of you, excellent. So in Java, is there a layer keyword? No, Java does not have a layer keyword. In Java, is there a component keyword? Same deal. What we're doing when we're programming is we're combining interfaces, classes, namespaces, packages, folder structures into things we call layers or services or modules or components. And sometimes that mapping from the code to the boxes on the architecture diagram is not clear. That's what this model code gap is all about. The easier way to explain it is if I were to grab somebody up and say, right, come to the front and draw me a diagram now of your software. You'll probably draw me a nice high-level picture. And that represents your mental model of how you view your system. It's like a nice summary. If I find some tooling to reverse engineer a diagram from the real code base, I'll get a totally different picture, won't I? The picture I get from the tooling is going to be very low level, very precise, but it's not necessarily how you think of the code from a developer perspective. So these are the sorts of problems that I want to fix. The bigger problem is vocabulary. So even in 2017, as software developers, we don't really have a good vocabulary to describe architecture. What is this a picture of? London? Yeah, it's a map of London. Perfect. What is the blue thing running through the map of London? It's the River Thames. Excellent. What is a river? What's a river? Flow of water, moving water. Yeah, so it's a body flowing water. It flows one way or the other. Right. So we learned this when we were children. We know what a river is, and we can go and identify other rivers. I did try to find a river on the map of Athens, but there didn't seem to be one. Well, there was yesterday, because we drove through them all. Something about the Greek weather. What is this a picture of? Right, it's a top-down floor plan for a bathroom. What is this thing here? What is it? I'm not repeating that on camera. Did you hear that at the back? So it's a toilet, right? We use the polite terminology. It's a toilet. What is a toilet? It's like a deathly silence. We're not in France. Okay, it's another body of flowing water, ideally one way.
It's a place where what happens we speak not of.
Right. And there shall be silence evermore. So again, we know what a toilet is. We hopefully learned this when we were fairly young. Some younger than others, some older than others. And we can use this knowledge to go walk around the building and find more toilets. If there are any electrical engineers here, what is that thing? It's a resistor, right? What is a resistor? Flows current or something, stops flow of current. Yeah, so we know what a resistor is. If I had a box of electrical stuff here, like capacitors and switches and resistors and LEDs, do you think you could come and rummage through the box and find me a resistor? Right, and if you knew the color coding, the stripes, you could tell me how powerful that resistor was. So again, we know how to identify a resistor. This is such an easy quiz, I'm going to step it up a bit. What is this? Yeah, this has got you all stumped, isn't it? This is our world now. We've gone from maps and toilets and resistors. This is our world. So this is a UML component diagram. Now, this is not a trick question. The clue is in the name. Given that this is a component diagram, what are the boxes on this diagram? Components, yeah. See, I told you it wasn't a trick question. What is our component? Oh, that's got you thinking, isn't it? That was worse than the what's a toilet question. At least somebody shouted shitter. A component is I don't know, it's a magic thing, it's a grouping of stuff. Let's look a bit closer. This one here says database inside it. So this is like a database component, like a database, I guess. This one says application. Is that a web app, or a mobile app, or a desktop app? Who knows? And what's this stuff down here? Are these microservices? Are they separately deployable components that live inside the application? I have no idea. Here's another example. I love this one. Look, it's got a business logic component. This is just a completely meaningless picture, yet this is the stuff we draw all the time. If you go look up the word component in a dictionary, it basically means part of. Imagine we're building a software system. The software system is comprised of a web app talking to a database. We could use the word component to describe the web application, or we could use the word component to describe the logging component. Same word, two very different levels of abstraction, and that's the big problem here. Anybody familiar with domain-driven design? So in domain-driven design, we talk about the ubiquitous language, a language that we as developers can talk with the business people about, the domain concept. The irony is we people in this room at the moment do not have a ubiquitous language to describe architecture. That's just bonkers. Obviously, UML tried to do this. If we go back and think about the electrical engineering diagram, if I draw a little squiggle, a zigzag, you know it means a resistor. I do think as an industry we need to get to that point, but we're way off that at the moment. So at the moment, I think a set of abstractions is way more powerful than any sort of common boxes and lines notation. And if this sounds crazy, let's go get two maps of Athens and put them out at the front here. The two maps of Athens will show the same things, won't they? The Acropolis, the metro lines, the bus routes, all the other ancient archaeological sites, shopping malls, districts. So the two maps will show the same things, the same abstractions, but they might use a differing notation, shapes, colors, line styles, symbols, and so on. How do we read a map? There's a key or a legend in the corner, isn't there, to describe the funny symbols we see on the map. So a map is a really nice, simple example of a common set of abstractions with a varying but self-describing notation. And that's a super powerful concept. So we have to kind of backtrack a second and say, well, what are the abstractions? And when I'm talking about a software system, for me, a software system is made up of one or more containers. Now, it's a bit unfortunate that Docker became slightly popular, because I'm not talking about Docker containers. So a container is basically an application or a database. It's a web app, mobile app, standalone app, batch process, data store, that sort of thing. It's a deployable unit. Inside these deployable units, I'm going to say are components. So I want to use the word component very specifically to mean something running inside a runtime environment. And because I mostly deal with Java and C#, my components are built from classes, and we're done. That's it. That's the set of abstractions I use to describe software. This works beautifully for Java, for C#, for C++. Any JavaScript developers here? I'm sorry. In JavaScript, you don't have classes. So in JavaScript, maybe this is components and functions, or better still, maybe modules and functions, because we tend to think about JavaScript modules. Same with C and other technologies. So take the hierarchical approach and blend it to your tech. Once you have some sort of notion of a set of abstractions within your teams, you can draw some pictures. And for anyone who's seen my work before, this is my C4 model. And it's a set of hierarchical diagrams that describe each of these levels in turn. And it's a way to kind of get an overview first, zoom in and filter the other stuff out, and then get details on demand. This is really echoing Schneiderman's mantra. So it's a simple kind of mechanism for dealing with big data sets. And this is really just about static structure. And it's static structure from the level of the system as a box we can't see inside of, down to the code, with a couple of levels in between and some good traceability. And it turns out, once you get the static model agreed upon, it's really, really trivial to draw other interesting views around it, dynamic and runtime behavior and deployment mapping and processes and that sort of thing. Quick example, so I'm from Jersey, in case you didn't guess. And when I moved back to Jersey in 2008, I wanted to create a website to basically aggregate content from other tech people. All three of them. No, it's slightly bigger than that. And techtribes.j lists local people, businesses, blog posts, events, tweets, and so on. This is what a context diagram might look like for my TechTribe system. So, very high level, that's the thing I built, that's TechTribes. There are different types of people, different user types, and different systems that I interact with. Again, very, very simple, nice and high level, just provide some context. If it was interactive, like a Google map, we select it, we pinch to zoom in, we expand out that system box, we get to see the containers inside it. We choose one of the containers, that one there, we select it, we pinch to zoom in, we get to see inside it, so these are components. We select a component, we pinch to zoom in, we get to see inside it, we get to code. So again, it's a really, really nice set of hierarchical diagrams that map onto that set of hierarchical static structural elements. Now, the reason for my Jersey advert, of course, is this is a set of maps. It's a set of maps on top of a real code base that we can use to zoom in and out and tell different stories depending on the audience that we want to tell those stories to. And it's a great way to help people explore a large, complex, potentially unfamiliar code base. So the abstractions are really, really important. And that's my starting point for all of this. We should talk about notation. Notation's very easy. Just make conscious decisions about your notation. So when I'm drawing diagrams, I'm trying to draw diagrams, and all of the boxes reflect things in my static model. People, users, software systems, containers, components. And what I do in my diagrams is I like lots of text in the boxes. I'm very explicit about the name and the type of the thing, and I also have a descriptive text, like a short sentence. And the reason I do this is very simply because this is what most architecture diagrams look like. Now, we joke that naming is hard. If naming really is hard, and this box has a name that's not quite right, there's a degree of ambiguity here, of course. So add more text, provide a nice at-a-glance view, especially of descriptions and responsibilities. Boxes are important, boxes are things, but the lines gluing the things together are equally as important. And again, just put some focus and some emphasis on the lines. Whether you want to show dependency or data flow, again, this is where the art of visualizing software architecture comes back into play. What's the story you want to tell? And a simple tip here is read your diagrams out loud. Web application reads from and writes to database. If that makes sense out loud, you're good. Have a key, have a legend, so this brings back the maps aspect, so describe your shapes, your color coding, your lines, your symbols, your acronyms, and I would recommend using shape and color to complement and supplement a diagram that already makes sense. So take a diagram, remove all the color coding, remove all the shapes, so you've just got basic gray and white boxes. Does the diagram still make sense? If it does, you're in a good place. And again, just use shape and color to add visual impact. Two examples, different versions of the same diagram. There's fundamentally no more information on the one on the right than the one on the left. But most people prefer the one on the right because Especially when you sit far, far away, you can start to make some assumptions you can't with the one on the left. What I'm really trying to do here is make my diagram stand alone like maps. This is an often controversial topic because one of the things a lot of the Agile evangelists have said over the years is you don't need to do any of these complex diagramming stuff. What you do is you grab a whiteboard marker and you have a conversation around a whiteboard. And when the conversation is finished, you erase the diagram. You need another conversation, you draw another picture, you erase the picture. And for me, that's just wasteful. I want to create some artifacts that are useful, they're effective, they're powerful, they're quick to create, and they also stand alone. And my top tip in all of this is when you're drawing architecture diagrams, do not think like an architect. Think like a developer. And if that sounds odd, what I'm really trying to do here is I'm trying to create a set of diagrams that are somehow connected to the real world, connected to the code, so that they're useful. So there you go, I've taught you everything I know about drawing diagrams. We're all good now. We can all go back to work on Monday and draw some nice pictures. And people love this stuff. I'm pretty fortunate I get to fly all around the world and teach people how to draw boxes and lines. It's awesome. And my workshop uses paper, pens and paper, and it really, really bugs people. Because there I am saying, write lots of text in your boxes, and now people are writing really small Sharpie markers, and it just hurts their wrists. And like, Simon, this is great, but we can't use paper. So what tooling do you recommend is always the next question. When I'm doing an upfront design exercise, I will use whiteboards and paper. It's the simplest thing that can possibly work. It's a nice, big collaborative space. It's great for collaborative design. It's great for pair architecting. So this is good. What happens when you want to present your diagrams to a customer in a proposal, in some formal documentation? Well, you have to get the tooling out. Who uses Visio here? One person, two people, good. Everybody uses Visio, yeah. Once you get Visio installed, of course, because it's not really part of Office. So there are a set of general purpose diagramming tools here that most people kind of get out. Visio, Omnigraphal, Glyphy is very popular these days with Confluence, of course. Draw.io, Creately, Lucidchart, there are millions of these things. Anybody seen Spider-Man, the movie? With great power comes great responsibility. The problem with general purpose diagramming tools is you can draw anything. And this is why some of the architecture diagrams you see on Google just look horrendously bad. It's just boxes and lines, but you have to be very, very careful about what you create. You also have to keep these things up to date individually. We have 3 versions of a diagram here. Each has a box labeled Twitter somewhere on it. If I want to rename that thing to something else, now I have to change 3 separate diagrams. Anyone using text-based tooling here? Plant UML, web sequence diagrams? A couple of people. So I see lots and lots of teams adopting this style of tooling now. So rather than using a general purpose diagramming tool to manually create your boxes and lines, you use stuff like Plant UML and web sequence diagrams as a way to create diagrams. And basically what you do is this. You write some text. So this is websequencediagrams.com. You write some text and it generates you some pictures. Really, really simple, mostly focused around UML. This doesn't solve the problem about renaming elements, but we now have text. And as developers, we like text, don't we? We have lots of tooling to support text. We know how to version control text and diff text. So text is a much, much easier mechanism to work with. The problem with text is you can't ask it questions. You can't say, here's a component of my architecture, tell me all of the other things that link to it somehow. To solve this, there's something called an architecture description language. Anybody heard of these? Nobody. Good. Because they're horrible. Basically, these are very domain-specific languages to describe architecture. Connectors, components, ports, and this sort of thing. There are a bunch of examples here I've listed here. If you go and look these things up, you'll undoubtedly end up on a web page that looks like it's come from 1998. And that's because these things are stuck in the past. They're still stuck in academic circles and research circles. There are a few people using these things in the wild for certain industries, but basically nobody uses them because they're horrible. However, what we're doing here is we're creating a model. And one of the things that's gone out of fashion in our industry is modeling as a way to describe software. I guess we should get this out of the way. Let's talk about UML tools. So there are lots and lots of UML tools, Archimate tools, SysML tools, modeling tools in general. Anybody used rational rows in the past? That's a good number, right? So rational rows was epic because what it did was draw horrible diagrams, yellow boxes with pink outlines when it didn't crash. This is what a UML tool looks like, and basically what you're doing is you're creating a model of your software system. So you're creating elements in the model that reflect things in your code base. And you drag these elements onto a diagram canvas. If you want to rename an element, you rename it in the model, it renames it everywhere. So this is the power of having a model. We can also write queries against models as well. Other tooling you can look at, static analysis and dependency management tooling. These are not really targeted for creating architecture pictures, but they will give you some reflection of your code structure. 2009. I'm going to take you all the way back to 2009. There was a virtual panel on infoq.com. Bunch of famous people here in the kind of software engineering space, and the question was, what do you see as the future of software architecture documentation? And they're all saying some interesting things. They're saying like, yeah, embed information, get information free with a click of a button, create documentation that readily makes sense to developers, especially those who are joining your team. Have we got here yet? No, because we're still using Visio. Let's look at the building industry. We always like to do this software building thing comparison. So let's imagine I task you to go and design me the next tallest building in the world. Do you get Visio out as your tool of choice? You do. No, you don't. But that's a crazy, crazy idea. What you do is you go and buy AutoCAD and you create a three-dimensional model of your software system. And then you create different views on that model, the top-down floor plan, the cross-sections, and all that stuff. Do you know the irony of this? So hands up, who's a software developer here? That's like most people. So we, as software developers, build these tools so that other industries can do modeling, but we can't do modeling ourselves. How crazy is that? It's 2017, you know, we're talking about building distributed systems that span the globe and artificial intelligence and machine learning, and we can't draw pictures properly. And furthermore, any pictures you do draw yourself are not connected to the code, so they have the potential to lie to you. So of course, one option here is if you have a code base already, why not just reverse engineer diagrams? Has anybody tried this? What happens if you reverse engineer a code base? You get a really messy diagram. Is that because your code is a mess? Maybe. Some people are nodding, yep, sorry. But sometimes it's just because these diagrams are showing you the wrong thing. So here's a really simple example for you. In the Java world, there's a framework called Spring. Spring does everything. That's all we need to know. As part of Spring, there's a part called Spring MVC, and it's a way to build model view controller web apps. And there's a sample application called the Spring Pet Clinic. This is the diagram that the Spring team used to describe the architecture. It's a three-layer architecture: controllers, services, repositories. You download the code, it looks like that. Very, very small amount of interfaces and classes. Now, I'm a big fan of IntelliJ. Absolutely love the tool, been using it forever. This is what you get from IntelliJ if you reverse engineer a class diagram. And it's not the tool's fault, it's my fault. I did try to move the boxes around, but it's basically impossible. There's no clean layout available here because I'm showing you all of the code and all of the links between the code elements. This is a toy app. It's got 20 or 30 things. Imagine if this was your enterprise system with 1 million things. You're just going to get a black blob. What we can do, of course, here is we can start to remove some of the things that really don't make sense from an architecture perspective. And this varies code base to code base. In this particular example, there are some model classes representing pets and vets and owners, and they're not important. They're just dumb data structures, so I'm going to ignore those. And there are also some utils. Now, we all have utility classes. Good. So let's ignore them. Let's assume they are not significant from an architecture perspective. If we do that, we can start to recreate a much, much simpler picture. And by dragging the boxes around, I can almost recreate the layer diagram. So we have at the top here the web controller layer, there's a services layer here, and there's a repository layer down here. It's my first time to Athens, my first time to mainland Greece. I'm very excited. I'm looking forward to going sightseeing tomorrow. I'm probably going to walk out of my hotel and get completely lost. But I do have my mobile with me, and I have data roaming. So what I can do is when I walk out of my hotel, and I'm looking at the street, I can fire up my mobile device, and I can switch to Google Street View. So now I have the Street View and the Street View on my phone. That's a really dumb way to navigate an unfamiliar environment, isn't it? It's showing me no more interesting information. What I need to do, of course, is switch back to the top-down overhead view so I can see my little blue dot and where the Acropolis is so I can start walking the right direction. When you're reverse engineering diagrams, it's much like Google Street View. It's just reflecting the code. And really what we want to do with this diagram is zoom up one notch to get back to, let's call them components. How you do this depends on your code base, of course. And what I'm going to do here is make a bunch of assumptions, but essentially these blue blobs I'm going to say are components in this given code base. And what I'm essentially doing is I'm bundling together things that should really live together. What I want to do is draw a diagram like this and remove all of the code level noise. Because this shows a much more interesting picture. Look, we can see this clinic service is like some weird pinch point, and maybe we couldn't see that before because the detail is being obscured. And the issue here is most tooling sees code. It doesn't see components and these logical building blocks. This is the whole model code gap thing again, of course. To further complicate this issue, that information does not typically live in the code anyway. George Fairbanks to the rescue. George is awesome. In his book, he says, well, why don't we just adopt an architecturally evident coding style? This is a very long set of words for basically saying, make your code reflect your architecture. Drop hints and metadata into your code base so that your code base reflects your architectural intent, the boxes you have on your architectural diagrams. This sounds very complex, very grand. It's very, very simple. What you do is you use stuff like naming conventions. So we have an architecture diagram. It has a box labeled logging component. We make sure that somewhere in the code is something called logging component. Maybe we adopt a namespacing or packaging or folder structure convention whereby every box on our components diagram maps to a namespace, a package, a folder in the code base. Maybe it's about adding machine readable metadata, Java annotations, C# attributes to signify what the important architectural building blocks are. You know, maybe you create your own @component annotation in Java. If you're using a framework like Spring or Java EE, you're probably annotating your code anyway with @message-driven, @stateless, and whatever. So maybe you just bootstrap and use those annotations. And that's really what I want to do here. I want to extract useful information from a code base, especially at the components level, and supplement it with stuff that's a bit trickier to find. And I want to combine all the tooling we've seen so far. And I want to use text, because as developers we like text. And I really like the whole architecture description language concept because it's about creating a model of our system again. But I don't like the existing architecture description language. So guess what I did? I wrote my own. Are you horrified now? I wrote my own. And the key difference between the one I wrote and the ones that exist already is that mine's executable. And what it really is something I call an executable architecture description language. And essentially what you do is you write code to describe architecture. And there are two open source libraries that implement this concept. There's one for Java and one for .NET. And what I'm trying to do here is I'm trying to create a set of tooling that is easy for us to use as developers. It fits into our regular tool chain, but we still get some richness of a model that we can do some interesting stuff with. So let me show you some code. I'm going to show you some code to Keynote, which is quite unusual. I'm going to describe the Spring Pet Clinic system using my architecture description language. And basically what I'm doing here is I'm writing a small Java program to describe the Spring Pet Clinic system. In essence, what these things are, essentially there are two class libraries, one for Java, one for .NET. And inside these class libraries are a bunch of classes that represent the things in my static structure. People, software systems, containers, components. And all I'm doing here is I'm kind of creating instances of these things and wiring them together. The Spring Pet Clinic system is nothing more than an employee of the clinic, the animal hospital, using the system. So we can just simply write some code to describe that. And we can say that the clinic employee uses the system. So there's a really simple API here to wire things together, to create the connections between elements. We get down to containers, we do the same thing again. There's a web application talking to a database. So we just model these things with code. We say the user uses the web application uses the database. When we get down to the level of components, I don't want to do this manual approach because it's error prone. And of course, every time we add a story or a feature or something, we change the set of components in our code base. So built into both libraries is a component finder. Now, they say naming is hard, but this just finds components. How does it find components? Well, that's up to you, because every code base is unique, of course. And this comes back to the whole architecturally evident coding style thing. So depending upon the conventions that you've used to structure your code base, you plug in rules that basically find your components, whether it's through naming conventions or subclassing a base class and so on and so forth. With Spring, we use annotations. So all I've done is I've built a Spring component finder strategy, and it goes and finds annotations. What you actually do is you run this program against the compiled version of the app, and it uses reflection and static analysis to go and find components. It also finds the links between components, of course. What you have here is a model of your components. In memory, it's a set of objects, it's a directed graph. And what you can do now is you can write some more, in this case, Java code to slice and dice the model. And it's really trivial to do things like, go find me all of the repositories you just found and make them use a database. In the class libraries, there are some view classes. These represent the diagrams we saw before, the context diagram, the container diagram, the component diagram. Again, you use the API to add elements to the diagrams, and there are some rules in here that stop you adding components to a context diagram. So again, I'm trying to create a simple, slightly constrained framework. And then we create some pictures. But there are no pictures here, of course. And you have a model. So you have an in-memory model, and once you have a model of your system, you can do anything you want with it. So built into the Java and the C# open source libraries is an exporter for plant UML. So you create your views, you export them to plant UML, you copy that definition into plant UML, you get some pictures. So now we've basically coupled plant UML together with a model. So we change an element name somewhere, it changes everywhere else. If there are any graph viz fans here, there are normally one or two kicking around, so there's a graph viz exporter. So you take your directed graph, you export it to graph viz, you get some really ugly looking diagram. I want pretty pictures for presentations, documentation, communication, and so on. So I built a web app called Structurizer. You can sign up for free, and all of the stuff I'm about to show you can do for free online. And basically what you do is you upload a description of your architecture, a JSON document in this case, via a web API, and you get some pictures. There's no automatic layouts, it's a very constrained notation. You can change the shapes and the colors and that sort of thing. And here's a context diagram of the Spring Pet Clinic system. It's the employee using the system. That came from the code I showed you. This is the container diagram. It's the employee using the web app using the database. This is the diagram I showed you before. This is the component diagram for the Spring Pet Clinic web app. All of these components were found automatically in the code. The description in the box, That's actually the top level Java doc comment. So what I've done here is I've also pointed it to the source code, and I want to use as many information sources as I possibly can to get a decent set of rich, simple pictures. Because this is a model, we can do silly things like generate diagram keys. It's the maps thing. This all comes back to maps. And what you can do is you can actually double-click a system to get to containers. So you double-click a container, you get to components. If you double-click a component, you get to, in this case, the source code page on GitHub. So we've got a simple way to create a set of maps on top of a real live code base. If you hook all of this sort of stuff into your build process, guess what happens? It takes a lot of work away from you around keeping your diagrams and your documentation up to date. So I want to get people back to modeling. Modeling's become a horrible, dirty word in our industry, but there's a real useful thing you can do with modeling, and that's querying. And of course, once you have a model, you can explore it in a number of different ways and ask it questions and also create additional visualizations. This is a JavaScript D3 tree structure of the Spring Pet Clinic system, and it's really easy to create. There's a system, containers, components, classes. If we zoom in, this is one of the components, and all of these things here are the code level elements, the interfaces and the classes found during that component scan. And we can use color coding to highlight them in different ways. So the gray shaded class names here are actually shared code between this and other components. And that's a really interesting thing to see about your code base. You know, where are we sharing code between components? You can do things like draw dependency maps. So what I've done here is I've drawn out a set of all of the components in the Spring Pet Clinic web app. I've selected this clinic service thing, and what this diagram is showing you is the inbound and outbound dependencies. And you could highlight cyclic dependencies with red or something. If you have some notion of size might be just lines of source code. You can draw some interesting bubble graphs of, you know, size of container, size of component, size of the code level elements. So that's me pretty much done. I have 2 slides remaining. Number 1, the 1990s is calling and it wants its tooling back. Please, please, please stop using Visio or Glyphy or any of those tools. This is 2017. We should be modeling. We should not be handcrafting software architecture diagrams. That is just a ludicrous concept, and I hope we get back to modeling at some point. However, having said all of that, remove all of the tooling part of this talk. Whatever you do, when you go back into your teams and you start having that whiteboard discussion, focus upon your abstractions first. Take 2 minutes, list out the abstractions you're going to use, and let that influence the conversation you're about to have. Do keep the notation in mind, and really what we're trying to do here is create a simple set of diagrams to tell the story you want to tell. That's me. Thank you very much. I hope you enjoyed the rest of the day.
Thank you, Simon. Fantastic. Alrighty, I think Simon, are you taking any questions? Is that are we doing that?
If we've
anybody got any questions? I'll run around with the microphone very quickly. I'll take 1 or 2.
A quick one. What is your definition of architecture? What do you understand by architecture?
What's my definition of architecture? I have a book about this. Available on LeanPub. So my definition of architecture is basically 2 things. It's structure. So you have a software system, you look inside it, you look at the building blocks and the relationships, so that's a structural element. And it's also about vision. So you have a blank whiteboard and some requirements. How do you translate those to a technical solution? And once you have that technical solution in your mind, how do you communicate it and visualize it to everybody else? So that's my short definition of architecture. It's also significant decisions.
Any more? I've got time for 1 more question. This is your last chance. There we are. Whenever I say last chance, that's like...
I will be here all day, so just grab me if you have questions.
Well, yeah, I was going to say that. Now, we're not going to let you go so quickly, you know.
Yes. What do you think about code generation from a UML diagram?
What do I think of code generation from UML diagrams? I don't like it. it is useful in some sectors. I do see people doing it. I personally don't like it.
Say no more. Okay, if we don't have any more questions, I'm going to release Simon from the stage.
Thank you.
Simon, thank you so much.
You're welcome. Thank you.
And I know you'll be available to everybody for the rest of the day.
I will.
And in a little while, in about 10, 15 minutes from now, we'll have a coffee break. So I'd like you to just keep in your seats because I want to invite our next speaker. But before I do, you'll see me scurrying around, trying to find the next speaker and ask them why they're so amazing and what I should say about them to introduce them. And I found one of the staff members of Advantage Financial Systems Experts, which is one of the key sponsors of the event. And these events wouldn't be possible without the generous support of organizations like this. And when I found Peggy, who is the head of happiness, from what I understood, that was her role, head of happiness. I heard something about happiness and culture. I said, so what makes you guys so amazing? Why support this event? She goes, well, we heard that the most amazing developers and professionals would be in this room, and we kind of think we're amazing, and we want, amazing people need to be in the same room. So we wanted to support this event, and that's why we're here. So I took the Socratic approach, and I'm like, but why? Tell me why. She goes, well, because we build amazing systems for the banking sector across the world, and we've got a great team. We've been profitable 15 years since the day we were born, basically, and we're awesome. Okay, but why? Well, because we have offices near the beach, and it's a great place to work, and we're listed on TripAdvisor as one of the best places to, and we've got locations in exotic places like Aruba and Santo Domingo and all the Caribbean. At that point, I stopped asking why, and I handed my CV. And I hope you do too. Let me invite Mr. Nikos Konstantinidis, who's the CEO of Advantage Financial Systems Experts. Nikos, thank you.
Is there a microphone here?